Hi. So what we are going to discuss now is what is Kafka and why Kafka is used, right? So let's assume an example where we are booking a cab or a bus. For example, I'm taking a cab here. So how do we get the location details of a cab, right? So the driver and we ourselves have an application installed, right? So when we book a cab, we send our location details and the cab driver also send his details, right? To let's just say a messaging platform. Here a common centralized system you could say. So when cab driver or the cab driver's application is producing a message, it is consumed by our application and it shows the coordinate details, right? So it says like the yes, the driver is approaching you, or similarly, the driver will be shown about our details like he's standing over there, right? So this is where Kafka plays a major role, right? So Kafka is a messaging platform in a way where it sits between the producer and the consumer applications, right? Now we are going to discuss about Kafka, right? So what makes it an ideal choice for applications to use it, right? So on the left hand side, we have its properties, or you can say why it's a good choice. Like it's a data streaming platform, it is highly fault tolerant, it's durable, and it follows a publish subscribe model, and it has distributed architecture, and it has very high performance. And here are a few use cases. So let's just dig into details. Now, data streaming platform. So as the name indicates, it's used to stream data and provides real-time updates, right? Last we discussed about locations, right? Location tracking. So it has to deliver the message from producer to consumer within no time, right? We can't expect a delay. And also in case of data analytics as well, if we are showing users this is the data consumed or this is the data we have analyzed and these are the metrics, right? We can't afford to lose or make the user wait. So this is where Kafka comes into picture. We have Streams APIs and Apache Flink. So Kafka is used in conjunction with these APIs or applications to provide a seamless data streaming platform, right? And it's fault tolerant. So we have a concept of brokers here, right? These brokers are nothing but servers where we host the Kafka applications, right? So we can increase the servers horizontally. Internally, Kafka handles all the sync with the other brokers. It has an offset mechanism to keep track of data processed, right? So even if, let's just say, we are sending few messages and consumer is consuming those, but unfortunately, consumer has gone down due to some application error or instance down, we have that. But when it comes up, right, we have consumer groups. So what it does is it knows from where it has to process the data, right? The consumer commits the offsets uh, to the topics, right? We have the offsets written. So that's how Kafka becomes more efficient and also fault tolerant. And coming to next, durable. So we store the messages on disk to ensure no minimal data, no data loss, right? So even if the consumer goes down or it didn't consume data, it can restart consuming the data, right? So this is useful where data integrity is critical. So let's say two systems are required to be in sync. So one system receives the data from some external application and it sends data to the system B. So both system A and system B require to be in sync. So we can't afford any data loss, right? And also publish subscribe model as we have discussed. There are producers and consumers to transmit data, and what it provides mainly is that flexibility of decoupling the services. So each service, though they are dependent, they can operate individually, right? So even if I want to scale application A, it doesn't affect application B, right? I can do whatever with application B. So this is where Kafka plays a major role in event-driven architecture. This is one of the design patterns of microservices. right? So next coming to distributed architecture. So we have discussed what brokers are, right? They are nothing but servers. So this data is distributed across the brokers in a concept of replication. So this replication of data, so if one broker receives the data, it replicates asynchronously to other brokers as well, right? So this is how distributed architecture is used in Kafka, and it provides a very high throughput. Coming to next, high performance. So we have high performance because there are several factors, like here we have sequential disk input and output, right? Kafka is designed for efficient disk input output by writing the data sequentially to disk, right? It writes in order. So this is more efficient than, randomly writing or randomly appending into files. So it leads to a better performance. It optimizes for scenarios where data is appended to logs, making it like it's well suited for handling high throughput data streams. So it's useful for log aggregating as well. So we have immutable logs. Those logs are both different. These logs are related to Kafka, and logs aggregation. This is related to application logs, right? So Kafka treats data, I mean, whatever the messages that it takes in, those are immutable. Once we write, it is done. It's never modified. It's either get deleted or it gets consumed. So that is how it is. Immutable. So it simplifies the data storage and retrieval. So, and also it helps in efficient batching or compression for handling high throughput data through streams, right? And we have next zero copy transfer. So what Kafka does is it uses zero copy transfer techniques when reading and writing data. This means the data is transferred directly from the kernel space to user space without any unnecessary copying, right? This reduces CPU overhead and also less memory usage. So it doesn't store the data anywhere, it just keeps it within the application, I mean the Kafka, right? So this is how it gives overall performance improvement and also parallel processing. It's just not that one consumer needs to consume from a topic. Multiple consumers can consume from a single topic, or multiple producers can produce to a single topic, right? This gives a more flexibility in parallel processing of the application. So these are few properties which makes Kafka more strong and highly preferable for asynchronous processing or event-driven architectures or making the applications decoupled. So we have discussed what and why Kafka is used, right? And we are going to discuss real-world use cases where Kafka is actually used within the applications. So event streaming, as we have discussed, to transmit the locations of the users uh, in a cab booking system, right? Uber uses it for tracking the locations on and activity tracking. So if I like a post or share a post or comment, right? So it has to reach the end user. So when I click a like button, it transmits the message to Kafka and consumers read it and process it and send it to the user. And recommendation system, we have Netflix, right? So whatever we watch, based on that we will get recommendations. So these recommendations are sent via Kafka. And financial services, so for maintaining data integrity as well, if a user performs a financial transaction, all the transactions needs to be ordered and Kafka maintains it, right? So this is one of the use cases where PayPal uses it for maintaining its platform. And coming to next, monitoring and administration, as we discussed, log aggregation or alerts or different metrics, right, of an application. If we are going to display on a dashboard, so Kafka is your choice. IoT systems, like from different geolocations, we might get temperatures or, right, humidity, whatever we want. We can send it from different locations to a Kafka topic, and from there, consumers can consume and perform necessary processing on it. And e-commerce, while placing the order, it involves numerous functionalities like payment, sending notification to the users, and updating the user order details, and preparing it for dispatch, right? So once the order is placed, I can just simply put it on a Kafka topic, and it can pick it up I mean, consumers or different consumers can pick it up from the topic and process it accordingly, right? And also next, telecommunications to process the signals or analyze the data and many more. So these are few of the use cases of Kafka, and we are going to discuss a lot of Kafka concepts or how streams are used, how connectors are used, right? So see you soon.